All this while we've been looking at how lasers work, the mechanism, and a few derivations on that front. Then we looked at the classification of lasers based on various criterion. Now in the rest of this lesson, we will be looking at three different lasers which are widely used in industry for a variety of applications. So we will look at what they are made up of, what their pumping mechanism is, what their active medium is, what kind of light they produce, and what applications they are used in. So the three lasers will be ND-YAG laser, semiconductor lasers, and carbon dioxide laser. So we will start with ND-YAG laser. So ND stands for neodymium, YAG stands for yttrium aluminium garnet. So the active medium is an alloy of all these materials: neodymium, yttrium, aluminium, and garnet, which is why we call it an ND-YAG laser. That's the active medium. The pumping mechanism is optical. A krypton flash lamp or semiconductor diode is used, and light is shown onto the active medium. This light energy is used to remove electrons from the ground level and fill them to the pumping level. Pumping scheme is 4 level, meaning your ground level and lower laser level are not the same. I have explained more about 3 level, 4 levels in a separate video on pumping schemes. So if you're not quite familiar with that, I would encourage you to watch that. Now construction and working. So this is the setup. So you have a flash lamp, which is the pumping mechanism. It is connected to batteries and so on and so forth, this is an electrical circuit setup to provide power to the flash lamp. Now you have an elliptical, this blue cylinder here is the ND-YAG crystal, first of all, which is your active medium, and it is placed inside an elliptical reflector, a reflector which is shaped like an ellipse. And at the two ends you have silver mirrors which act as the actual reflecting bodies. Now why ellipse? Because the elliptical shape focuses most of the light into the reflector setup again. So if you remember from your knowledge of conic sections, an ellipse has two foci, and anything that is shaped elliptically, and if you're going to throw some ray of light or heat or some waves are incident on it, everything will get focused at the foci, so concentrated at the foci, so to speak. So the purpose of the elliptical setup is to make sure most of the photons are concentrated within the medium and loss of photons or leakage is avoided. The silver mirrors are the actual reflecting bodies. The blue cylinder in the image is your active medium, the ND-YAG crystal, and the pumping mechanism is the flash lamp. So talking about the working, so when the flash lamp is switched on, pumping begins first of all. So this light energy is used by the ground level electrons to go to the pumping level. From there, non-radiative fast decay come down to the upper level. From there, first some spontaneous emission takes place, then those photons trigger stimulated emission, and then the rest of the story is the same as what happens here. So the only thing that is specific to ND-YAG lasers which you have to know here is the pumping mechanism is a krypton lamp. So yeah, that's it. So if you're asked to talk about the working, you just start by mentioning the krypton lamp, and then the rest of the phenomenon is just the same. Output characteristics, this is the wavelength. It can produce continuous or pulsed light. Here's the power. These are some of the applications, and this is the energy level diagram. Ground level, lower level, upper level, pumping levels, and these are the energy gaps between the levels. So that is an ND-YAG laser.